So I'm just opening an example. Okay, I'm just waiting for the screen to refresh. Hopefully it's not as slow for everybody. So for the bill of material, some people, of course, will call this a recipe or formulation, but essentially it is what you need to do to produce a product, consuming what materials are needed. So materials could be raw material, could be packaging material, could be semi-finished goods. So for the BOM, you would notice that the bill of materials screen for Autosimply allows you to define multiple BOM numbers and revision numbers to produce the same product. So just to quickly compare that versus the IC BOM that you might be familiar with. In IC, you have the BOM code or the BOM number, but that's only one field. In Autosimply, we actually support two, which is the BOM number and the revision number. The combination of the item number, the BOM number, and the revision number gives us a unique BOM record. So for most companies, big changes to the BOM would be a different BOM number, and then small changes could be a revision number. Notice how we also have here a BOM status. So this flag allows us to control whether a BOM would be actively used in the system or not. So that means for a typical manufacturer, initially, a new BOM being created would have a status of under development. And then once it's ready for use, it would be changed to approved. If something goes wrong, it would be set to on hold, so that prevents further processing of orders. And then lastly, once let's say the product becomes obsolete, you can set it to discontinued. Another field here that some of you might be familiar with is called the standard batch size. So this batch size is very similar to what the IC BOM build quantity represents. So this is the proportion between the product, how much product is produced using how much of components. So for most, let's say, electronic companies, the standard batch size would be one. So one computer, one calculator, one product. But let's say if we're dealing with a, let's say a process industry, let's say a food manufacturer, then the tendency would be the batch size would be for a batch. So it could be 100 kilos, 100 meters, or 100 square feet of something. So that's the batch size. One major difference between the IC BOM and the manufacturing BOM would be the operation tab. So I clicked on the operation tab. It should refresh soon on your end. And here you would see what we call operations. Some clients or some partners would call this item routing or routing. Essentially, it's just telling us what steps or process are involved in producing the product. So in my example, I'm showing two operations. I have operation 100, which is assembly, and then operation 200, which is packaging. Let me just double check if, okay, it just refreshed from your side. So for each operation, you would notice how the operation code 100, for example, is linked to a specific work center 1. So imagine if this is a manufacturing environment, then when I'm doing assembly operation, typically I would need a assembly machine or assembly work center or production line to do it. The same goes with packaging. So as I do packaging, I would need a packaging machine or work center to do packaging. Notice how we could define standard times for each operation. So for example, when I'm doing packaging, here I could set up the system that I would expect to need zero point 0.2 hours or minutes to do the setup for each unit of the product. So whether it's piece, kilo, or meter, how many minutes or hours does it take to produce that one unit? For some industries, they have a need for cleaning prior to the setup. So notice how here we can set up a standard cleanup time as well. So again, this could be in hours or minutes. So for each operation, we would have a standard time, which is useful for cost calculation as well as planning. Aside from the operation information, notice how we have at the bottom left corner of the screen, what we call resources. So this resource referred to non-inventory costs that are associated with the production process. So a very good example of this would be labor, whether it's run labor or setup labor or overhead, subcontract cost. So we can define any number of resources, link them to the work center so that whenever a operation uses a work center, the system can then automatically populate what resources will be assumed to be consumed. So notice how the resources would refresh as I move from one operation to the other. So assembly can have its own resource. So imagine assembly having a run labor different from packaging, which would have a packaging run labor or setup labor. That is the operation tab. The next tab that I would focus on is the component tab. So this is a bit similar to the bill of material list that you might be familiar with in IC-BOM. Here I could define what materials are needed to produce this product. In my example here, I actually included one semi-finished good, let's say 2 direct raw material items, and 2 indirect packaging materials, for example. Notice how for each component, it is linked to an operation code. So that means the system knows at what stage of production is the material needed. So that means from a warehouse control perspective, I could issue materials to the production floor based on operation if we wanted to. The quantity column here indicates how much of each component is needed to produce the batch size of the product. Location code refers to the Sage IC location where we source raw materials from. So unlike in IC-BOM, where you are forced to limit assembly transactions to a specific location code, in manufacturing, you can actually source each component from a different location. The system would know by default where each material would be coming from. And of course, we can even still change this during the actual MO processing or issuing of material. So let me just scroll to the right a bit. So here you can also see a column called percent scrap. So this is another feature that we have that IC-BOM cannot support. When we say percent scrap, we are actually referring here to expected losses during production that the system needs to take into account. So if I put in here a value of 10%, what it means is that from a planning and cost calculating perspective, the system would need to add 10% more. So depending on the industry, this could be referring to, let's say, spillage, loss, or unavoidable damages being done during production process. It prevents shortages when we do production runs, because there's already an allowance that we apply. It's also quite similar to yield percentage. So some clients, they actually refer to this as yield percentage, where they say, let's say, for example, that a production process would have a 90% yield percentage. So that means they expect roughly 10% loss. However, when we use yield percentage, it can only be expressed as a property of the product, and it assumes that the 10% loss is applied throughout the BOM. So in Autosimply, just to make it more flexible, what we have done instead of yield percentage is put 8% scrap. So if we put 10% for a specific item only, then only that component will have that 10% loss. So a good example could be during production run, the loss is only happening at the assembly step. So that means on the packaging operations, maybe there won't be any loss. And by using this method, we can prevent that, or we can at least support that functionality. Now, for those who are quite familiar with manufacturing order already, you will notice that in the latest versions of MF, we have actually added 3 more columns there under the component tab. We have included a unit cost field, extended cost field, and a scrap cost field. So this is just to simplify or share this information with the R&D team as they create their BOMs, so they could see the breakdown of the rolled up standard cost for the finished good item. Now, aside from the components and operation tabs, we do also have a version tab. So this version tab is meant to serve as the bridge between the ERP BOM and your PDM or PLM solution. So PDM refers to Product Development Management Solutions. PLM is Product Lifecycle Management Solutions. A more commonly heard term is like AutoCAD. So if the client has to design certain products using AutoCAD, typically you have data that resides either on the AutoCAD solution or on the PLM solution. And the version tab is mainly meant to bridge the ERP BOM that we use versus the BOM drawings that they have in their PLM solution. So one thing to highlight here is that we don't market manufacturing order as a PDM PLM solution. So we only define the BOM for use in ERP. We can only bridge information between the two solutions using this version tab. We also have here an instruction tab where the client can define any number of instructions or comments that they want to link to this BOM record. So that means when they create a manufacturing order or a job order, they can use this instruction tab specific to that BOM record to show there what they should do, what they should not forget, what they have to do next in certain steps. Now, the next tab here is co-product. So this is, again, something that IC BOM cannot support. The purpose of a co-product in manufacturing is that it accounts for recyclable or scrap items that are produced together with the main product. So it could be, let's say, for the metal industry or the steel making industry, whenever they cut steel or metal, or whether it's plastic or leather, there would always be some trimmings. And this trimmings, maybe there's some value to that. The client wants to track how much scrap or recyclable items are produced during the production run. These co-products, as we call it, are received into stock in IC and can be sold or reused at a later time. So in the newer version of MF, we actually now allow you to define costing for this co-product. So for the longest time, we have always told partners that one of the limitation of co-products is that it will always be received to stock at zero cost. But now in the newer versions of MF, in the MF options, we can actually set up the system to receive co-products at standard cost, and or actually let the system distribute the costs proportionally based on the quantity produced for the main product versus that of its co-products relative to standard costs. So now there are actually 3 cost methods that we can apply for co-product. This is something that we have added on version 6.7. So I'll try to show that to you later on. So there is one quick question here about linking drawings to shop floor. So for shop floor, that's actually a separate module in manufacturing. It's maybe just for those who have no idea, for the manufacturing suite of Autosimply, it's actually comprised of 4 modules. So you have the manufacturing order module, we have a production planning module, there is an option for a manufacturing lot add-on, as well as shop floor control. So just to quickly answer that question, the drawing can only be linked to the BOM. And then the BOM is linked to the manufacturing order, which is in turn linked to shop floor. So essentially, the answer would be yes, there's a drawing that can be linked to shop floor. However, the limitation would be going back to the version tab, you would notice that I could only link one drawing to the BOM record. So if the question is implying that I would have a lot of drawings that might be specific to a operation within the shop floor control module, then this won't be sufficient. So one common or one thing that we would suggest is maybe instead of thinking of adding more source documents here, what you could do is make use of Document Manager by ORCID and link multiple documents to the BOM. Okay, so that's just one of the things that you could do in terms of drawings being linked to BOM. But again, just to be very clear, out of the box, we only allow one source document to be linked to the BOM. All right. And then there's another question regarding BOM numbers. So how many revisions could be supported in the BOM? So the quick answer to that is it's unlimited. You can have as many BOMs, BOM number or revision number linked to a product. Notice that there is only one default BOM. So even if you have 10 bills of material for the same product, only one would be default. And then you can have all 10 as approved. So that means the production personnel can actually have the flexibility to use any of those approved BOMs. One quick thing to highlight here is notice that aside from the BOM status, we also have effective dates. So that means it's possible for you to have an approved BOM, which is scheduled to be discontinued by, let's say, end of the year. So on January 1, 2021, the user won't be able to use that particular BOM if you have set it up to be discontinued. Now, just one quick reminder here. The the dates referred to here in the BOM is being compared versus the server date. So that means, of course, for clients, this is not an issue. We assume server date is the right date. But for partners, just note when you do demonstrations, some of you tend to use like 2021 or 2022 as the session date. And if you create a BOM with an ineffective date, then that won't show up during your presentation. So just be careful about that. All right, so there's another question regarding percent allow column in the BOM component page. So let me just go back there. So I'm just waiting for the screen to refresh so that you won't get lost. So a while ago, in relation to this, we were talking about the percent scrap. So I hope percent scrap is clear. But for percent allow, this is actually a reference field that we have added into the BOM component tab. It does not affect the system in any way, but the practical usage of it is sometimes when we outsource to subcontractors, there need to be a like a negotiated allowance for loss. And this is our intention here. So you could put a value on the percent allow field for use in reporting or doing some analysis, but it does not affect the BOM or manufacturing order in any way. So there's one more question. When the discontinued date arrives, okay. So the question was, if we have set up the discontinued date, will it automatically change the status of the BOM to discontinued upon arriving at that date? The quick answer to that is no. It won't automatically change the status, but the logic of the system is actually looking at both the status and the effectivity date of the BOM. So still, if the discontinued date is if the BOM, if the system date is beyond the discontinued date, then the system will not allow you to use that BOM anymore, even if the status here is approved. So just to be clear, we don't update the status. That one has to be done manually. All right. So that was just fielding some questions in connection to the bill of material. The last tab there is just optional field, so I won't spend too much time on that. Most of you guys already know what optional fields are in Sage, and this particular optional field is, of course, linked to the BOM, just in case there are information relevant to the BOM different from the item. But in our experience, most clients actually put optional fields on the item rather than the BOM. Now, that's the bill of material. The last thing I just want to highlight here is that notice we have a copy BOM function. So just in case somebody asks how many revisions of BOM we can do, this copy function here allows you to copy one BOM to a new record. You can then change, and then it's the faster way of maintaining BOMs, assuming that the products are quite similar in nature. Now, while talking about the copy BOM, just be aware that under the periodic processing, we do have copy BOM to IC function as well. So even though we don't use IC BOMs, we don't use IC assemblies, we have added this functionality here to let you copy bills of material in manufacturing order to IC BOM for whatever purpose that may serve the client. So notice how when I open the copy BOM to IC function, I have here the option to actually source it from a BOM record or even an MO. So one particular usage of this is sometimes some clients need to do disassembly. So manufacturing order does not really do disassembly. We don't have a disassembly step, but we know that IC has. So instead of duplicating that functionality, what we have done is added a function for you to copy a BOM record, either from a bill of material or from an actual MO, copy it to IC, and then let you do IC disassembly or assembly even in inventory control. So just know that it's there. Another quick thing about BOMs is note that we do have a BOM import utility. So we expect all of the BOMs to be imported into the system via this utility rather than the standard Sage file import export function. The reason for that is because we found that there is a limitation in Sage replace function on the third level of data. So our BOMs has 3 levels. So the BOM header, the BOM operation, and the BOM resource. So if you just use the file import export function, there could be some problem when you try to replace the resource data. So instead of the file import export, what we want you to use instead is the BOM import utility. So essentially it's the same. We even provide for templates. So what we want to happen is you should create manually first one example of a BOM, export it out. You can then see how it looks like from a data perspective, copy paste it to the template, and then import using this tool. All right. There's one quick question about disassembly. So the question was, wouldn't the reverse MO be the same as disassembly? And the quick answer to that is actually the reverse MO would reverse the whole MO. So if the disassembly is just to be partial, so for example, I have an MO for 1,000, somebody wants to disassemble 1. So if you use reverse MO, then it would reverse all 1,000 of them. So if the need is just 1, then the quickest way to do it is via disassembly routine of Sage, maybe by copying the MO BOM. All right. Now, going back to the bills of material, let me also highlight here that we do have a substitute item table. And here I can define substitutes that can be used during the production processing. Your screen is not yet refreshing, but the substitute item here is very similar to maybe the OE alternate item. The main difference is the OE alternate item is mainly reports only. For substitute, we can define materials that can be used to replace other materials if there's not enough stock during the MO issuance stage. So, yep, I can see the screen just refreshed. I just want to highlight here that we can define the proportion. So maybe depending on differences in concentration or dimension, you might have to use more or less of the substitute, and this is something that we can define. Another quick thing to highlight here is notice that we have a separate standard cost definition. So for most of you, you would be familiar with the standard costs being defined in the IC location detail table in inventory control. And the main limitation of that standard cost field is that it doesn't have a breakdown. So when you define standard costs in IC, it's only a total. But for the purposes of manufacturing, we need to be able to break down the standard cost of a product in the different cost buckets that we are showing you right now. So you have material costs, you have packaging material cost, you have setup labor cost, run labor cost, overhead cost, subcontract cost, and tool costs. So the idea here is that we want the users to define standard costs via this screen. So anything that is purchased, let's say for example, raw materials or packaging materials, they should define standard costs in the MF item cost maintenance instead of manually calculating the standard cost of assembled items. In MF, we actually have a under the periodic processing, a BOM cost rollup function. So this routine will automate the refreshing of standard costs for all assembled items, whether it's a semi-finished good or a finished good item. So every time, let's say for most companies, standard costs are updated on a yearly or maybe quarterly basis. So the process should be the cost accountants define the standard costs for the packaging and raw material costs in the item cost maintenance. They would then trigger a BOM cost rollup. This automatically calculates the standard costs for finished goods and semi-finished goods from top to bottom. And if the intent is to use standard costing as costing method in Sage, we also provided a copy standard cost function to IC. So this routine will allow you to synchronize the costs or the standard costs of inventory control and that of manufacturing order. We actually even have here a copy item costs from IC function. So this is assuming or in case the client wants to use, let's say, the average cost or the last cost in IC to serve as their standard costs for the raw materials and packaging materials. So all of this are found in the periodic processing of MF.